In today's lesson, we're going to learn how to solve multi-step inequalities. They follow the same rules as solving equations, except when you multiply each side by a negative number, you must flip the sign. So if you have a less than, you switch to a greater, greater, you switch to a less. When you divide each side by a negative number, you also have to flip the sign as well. Another important difference is that an equation has one solution and an inequality has many solutions, as stated right here. As a reminder too, this sign here that makes an L is going to be a less than sign, since it is facing the same way as an L would. And this sign here is going to be a greater than sign, because you could not make an L out of it. And when I mean make an L of it, I literally mean to write less with this symbol up above. Looks like an L, just like you had it. Let's go ahead and solve A and B. For example A, go ahead and subtract 1 on each side. That's the only way to move it from the left to the right side. 8 minus 1 is 7, and we're left with x divided by 3. Since it's a divided by 3, the only way to undo that is with the opposite operation, which is multiplication. So we multiply by 3 on each side. That cancels out the division of 3, giving you just x on the left. And 7 times 3 equals 21 on the right. When x equals 21, that's the only options for the solution, so we call that one solution. And again, up here, an equation has one solution. Next example B is x divided by 3 plus 1 is less than or equal to 8. So that's an inequality, but we still solve it the same way by subtracting over 1. That makes again 7 like we had before, keep the less than or equal to sign, and then we multiply by a positive 3. So no change of sign needed. We just get x is less than or equal to 21. The most important difference between example B and example A is that this one has many solutions. Some solutions, for example, would be 11 because that's less than 21. We also could put 21 because of the equal to underneath. We couldn't put like 30. That would be greater than. So we have to do any numbers below or equal to 21 as our solution. Next example C, again subtract over the 2 on each side. That cancels out on the left. We're left with negative 5x equals 30. And then we divide by negative 5 on each side because it's negative 5 multiplied to that x, so we have to do division the opposite. Cancels out on the left, and 30 divided by negative 5 is negative 6 here. X equals negative 6, and that's the only solution since it's an equation. For example D, we do the same exact steps. So we go ahead and subtract 2 on each side. That leaves me with negative 5x is greater than or equal to 32. Then we divide by a negative 5. Now, because it's an inequality and we just divided by a negative number, we have to go back and look at our notes that anytime you divide by a negative number, you must flip the sign. So I'm right away going to change this sign facing the other way as they less than or equal to here. Keep the x on the left, and we know that we get on the right 32 minus 2 is 30, so double check that. Make sure you got that down. And then we get 30 divided by negative 5, which is negative 6. So solutions are x is less than or equal to negative 6, and that's many solutions because some solutions would be negative 6 since it is equal to, as well as numbers below that, so like negative 20, negative 100 even. Those are some possible solutions, but there's many, everything below negative 6.
In example E, I have negative 16. That is less than 7x plus 17. I want to get x by itself, and I see that I have a plus 17 on the same side as my x. So I'm going to do the opposite of adding 17, which is subtracting 17. And what I do to one side, I have to do to the other. It cancels out on the right side, leaving me with just a 7x. And on the left side, I do negative 16 minus 17, which is negative 33. I go ahead and divide each side by 7. That's the only way to separate the 7 that's multiplied to the x. It cancels out on the right side. And on the left side, I'm actually going to have a decimal, but I can leave it as this fraction as well. So we're going to go ahead and write the solution. When I am rewriting this one, I want you to make note that you will keep the opening of your inequality sign towards the X here. So if we think about this like way back in middle school as an alligator, the alligator's opening to the X, so it has to stay opening when I write it with X first in the format. Then I keep the fraction I had. So just make sure that you keep it open to the X like it was in the beginning. This is going to be harder to graph unless we change it into a decimal, and the decimal is around negative 4.7 when you actually divide that in the calculator. I can put that on my number line right between negative 4 and negative 5. Open circle because there's no equal sign underneath. And because I rewrote it in this format here, with X being on the left side and a numbering on the right, I can actually make this into a nice arrow sign to show me which way my graph is going. But that arrow sign trick only works when your variable is written on the left side, which is why we did a rewrite for this problem. In example number F, or letter F, we have 2 parentheses x minus 9 subtracted by the quantity of 3x plus 6, which is going to be less than our negative 22. I'm going to start with distributing the 2 to everything in my first parentheses. When you have parentheses, that's a great way to start. 2x minus 18, because I multiply 2 to the x and 2 to the negative 9. I will also have to distribute for the next parentheses. I love to write in the hidden 1 here. That follows after our negative sign, but before the parentheses. That way I know I'm distributing a negative 1 to the 3x to make negative 3x. And I'm also distributing the negative 1 to the 6, which makes a negative 6. The right side's going to stay put. I was just combining everything I could distributing wise on the left. Speaking of combining, I'm going to go ahead and combine my like terms on the same side on the left. I'm going to go ahead and highlight anything on the left that has the letter X in it. Those will combine together with the same operation since they're on the same side. 2x minus 3x is a negative 1 with x. Now on that left side, I'm going to highlight anything that is just a number, no x with it. That's the negative 18 and the negative 6. Those combine together because they're on the same side, keep the same signs. Negative 18 minus 6 is negative 24. Again, I'll keep my left side, simplified, and then I'll bring down my right side here. From here now, I don't have anything that's left on the left side that I can combine. So this is when I start doing the opposite operations. I have a negative 24 that's next to my x, so I can easily add that from one side to the other. Cancels on the left side, leaving me with just that negative 1x. And on the right side, I do negative 22 plus 24, which is 2. From here, to separate the negative 1 that's multiplied to the x, I go ahead and divide each side by negative 1. Cancels out on the left side. And on the right side, I do 2 divided by negative 1, which is negative 2. But let's highlight this step because what did I just divide by? A negative number. When I divide by a negative number, I always and forever have to switch my sign. So because of that step, we got to do the sign switch. Sign switches from less than to greater than. That's my solution. I can go ahead and write it in here. x is greater than -2. No need to change how it was written since the x was on the left side. From here, I do an open circle at -2. And then I go ahead and draw my graph so it is going greater than that value. Again, how I know which way to draw it is when my variable is on the left side, I can make that inequality symbol into a little arrowhead to show you what my graph is going to look like. Cool little trick, but remember it only works when the letter's on that left side. We're going to deal with some fractions. So do you have a fraction being distributed? First step will be to get the parentheses all alone here. After the parentheses is all alone on one side, then we will go ahead and multiply each side by the flipped fraction, also known as the reciprocal, to cancel. Let's go ahead and show you what that looks like. We're going to start with taking a look at example G, noticing that we do have a fraction of 1/2 being distributed to the two terms in the parentheses. From here, when I go ahead and do the reciprocal of 1/2, I just flip it so that way the 2 is on the top and the 1 is on the bottom. I can simplify that down. 2 divided by 1 is 2. So that's what I'm going to start my problem with, is I'm going to make sure, first of all, that my parentheses is all alone with that fraction multiplied in front of it, and that is true. Parentheses, nothing else besides the fraction in front. And then I multiply by that reciprocal, which is 2 for this problem. What happens on the left side is it cancels out here. The 2 and the 2 cancel, and when I'm left with just a 1, which is that what I will distribute to my parentheses here. What I have on the right side is 10 needs to be multiplied by 2, and that's 20. From here, I distribute 1 to both the x and the 4. That's just going to be 1x plus 4, and that's still less than or equal to 20. From here, I go ahead and subtract the 4 over to get x by itself. Opposite of addition is subtraction. It cancels out on the left side, and on the right side, I have 20 minus 4, which is 16. Again, I'll write that as my solution. No need to change how it's written since the x is on the left here. But now I have to shade all the numbers that satisfy the solution. This word satisfies means that it's just in the inequality here. So I want to select all the numbers, I'll circle it, that are less than or equal to 16. Well, 16 is less than or equal to 16, so we'll shade it. 20 is greater than 16, so I can't circle it. That's not a solution that satisfies this inequality. -18 is definitely less than 16. Shade it. It's a solution that satisfies this inequality. 100 is not less than or equal to 16, so we can't shade it. Next example, we're again seeing that we have a fraction of 3/4 multiplied in front of parentheses here. So I will talk about what the reciprocal is, which is just flipping 3 over 4 to be 4 over 3. From here, the biggest thing is that I have to do something first because I see for this problem that I have my parentheses, the fraction in front, but then I have this plus 6 afterwards. I want to move that first. That's my first step here. So the opposite of adding 6 is subtracting 6 from one side to the other. Cancels out on the left side, leaving me with 3 over 4 multiplied to that parentheses of x plus 3. On the right side, 15 minus 6 is 9. Now I finally have that parentheses all alone with the fraction multiplied in front of it. Now and only now can I multiply each side by that reciprocal. 4 over 3 on the left times 4 over 3 on the right. What happens on the left side is we go ahead and cancel out the 4 and the 4 on the diagonal and the 3 and 3 on the diagonal. What's left is just the parentheses of x plus 3. On the right side, a little bit of fraction math, but here's how I do it. I make sure to put 9 over 1. That way I make it a fraction. This way I'm multiplying a fraction to a fraction, and I know I can just multiply the two numbers in the numerator. 9 times 4 makes 36. And I can multiply the two numbers in my denominator. 1 times 3 makes 3. So making that whole number of 9 into a fraction by placing it over 1 helps me multiply what was in the numerators and what was in the denominators. From here, it's just a division problem. 36 divided by 3, I can do in my calculator or in my head, comes out to 12 every time. From here, all I have left is x plus 3 being less than 12. Well, it's a plus 3, so let's subtract 3 from one side to the other. Cancels out on the left side to just an x, and I can do 12 minus 3, which is 9. Your answer is x being less than 9. Shade all the numbers let's highlight under this line, this, bold this, cloud this, are not solutions. So now I want to think of numbers that are going to be greater than or equal to 9. If I have anything else, which is numbers less than 9, that's a solution. I need a not solution. So let's take a look. 0 is less than 9. That is a solution, so we're not going to shade it. Next one is 9 here. Well, it's only a solution if it's less than 9, so equal then is not included, so I would shade this 9 here. If you want to, you can use kind of X's to cross out which ones are not just less than 9. Negative 15 is less than 9, so not going to cross it out or shade it. But taking a look at 100, that's greater than or equal to 9. So that is not within the less than 9 range. So that is a solution we shade to be a not solution. It's kind of weird to think backwards, but you just think of everything that is not less than 9, like the